Alright, this is part 2 of inside a solar panel. Here I have drawn out individual solar cells, and this gap here represents N, the number of cells in a particular panel. A 100-watt panel will have 36 of these cells in it. The output voltage would be from here to here. Solar cell 1 plus solar cell 2 plus solar cell 3, and a 100-watt solar panel has 36 cells in it, so this V out is going to be approximately 36 times 0.6 volts. Now, to be complete, a lot of solar panels will have a bypass diode. Now, this diode is not used to represent energy production of the solar panel. It's a protective measure to prevent the solar diodes from being reverse biased and burning up. If any particular cell fails here and you have more than one panel, this bypass diode will take energy from a lower panel and pass it on to the next panel, thus giving you some output. Now, you could lose power from a panel from a failure of a diode, one of these circuits, or shading. Okay? It doesn't matter which. The series resistance can be summed up as N times the resistance of a single solar cell. The shunt resistance also can be summed up from the shunt resistance of a single solar cell. And the diode voltage adds up. You got 6/10 here, 6/10 here, 6/10 here. So the number of cells, the output or open circuit voltage, will be approximately 36 times 0.6. The current does not add up. They're all the same value, assuming equal light on each cell, and is basically constant. So we have a series resistance that's very small. It's on the order of 5 or so milliohms in a single cell. If you got 36 times 5 milliohms, it's still small. This varies typically from 10 to 100 ohms per cell. And if you got 100 times 36, it's relatively speaking very little currents going through that. So we say it goes to infinity because there's so little current going through it, we ignore it. Okay? So V out, or the open circuit voltage of a solar panel, is determined by the number of cells, and the limiting factor, what limits the voltage on a solar cell, is this diode.